Nelia Mazula of Dassault Systems, and Rajul of Infosys. Without further ado, please welcome Nelia.
I'll just present for Rajul today. Rajul's background is also on engineering information management by a number of years in business strategy, program management, and innovation. So we'll go through the why multi-asset management. We'll talk about configured integrated systems, and then we'll go through a use case about with multi-asset strategy. So why multi-asset management? Is really when you ask why, you want to know where, what, how. You want the full breadth of the why. And just to begin our webinar, we have a poll. So if you don't mind filling in your poll question here, what are your first impressions of multi-asset management and needs? So you have 4 options here: must-have, interesting, concept, lukewarm, and I don't think there's any value. So as you're filling those in, we'll capture those and we'll get those later. So why? Market challenges. I think we've all seen a version of this graph: retiring knowledge, increased regulation. Another big problem in the process industry and the capital industry is aging infrastructure. A lot of uncertainties, coming out of the oil and gas space. Definitely the price of the product of oil and gas. The commodities market has been complicated, but you also have global market fluctuations that contribute to that. And then the public scrutiny, in the industrial space, whether it's chemical manufacturing or oil and gas, there's a lot of these unknowns to the average Joe, and there's a lot of scrutiny because they don't know, all the details, and that's scary to people. So the branding of that and educating people is always part of the space. This is a study that we did with IBM. It's available on the internet. There's a link there on the bottom. We went and talked to a number of IT and line of business executives about where they see their challenges from an asset capital project management perspective. And, of course, number one, I think that's something of a no-brainer, total lifecycle cost. Everyone wants to optimize cost and revenue. So what becomes interesting is we start drilling down this graph. So and what we really are looking at here is most of these are having to do with revision and change management. So you look at things like need for repeatability of capital projects, and that's feeding into this multi-asset view. The first project should make the second project more cost effective. We should be leveraging from our best practices. In 2015, we should really be leveraging from our best practices in a digital way. Increased price of fixed bids is another one where you're saying, well, the price essentially is the same. We need to know before we walk into this project where our margin opportunities are and what the real cost in schedule is to deliver this. And that only happens when you're capturing and digitizing those best practices. There's other things in here, of course, that are challenging. When you're dealing with changes in IT technology and dealing with infrastructural changes. Of course, you have all this data sitting in one place. You need to migrate it. All of the environmental locations, costs, expenditures. So really, at the end of the day, it's the fluctuation within the enterprise that is making it harder to capture siloed information. Not only capture, but so what we really need is the transparency, repeatability, globalization. If you kind of boil down that questionnaire to 3 areas, and if we look at that from a business process perspective, really we're talking about change management or revision management strategy. So not on the governance side, but from the information management side. And repeatability, we're looking at it from a plant and industrial focus, right? We want to repeat these capital projects in a transparent and cost-effective way as we're doing these from one project to the other one. And globalization is pointing out the need for scale. We have other studies that we've done where we talk about internal and external collaboration, and that's all dealing with scalability, and I'll touch on that in just a minute. So intellectual capital essentially is how we circle that. So a lot of times people will come and ask, well, we can do this with our resource planning technology and our back office technology. Well, when we start to look at the business, the industrial side, and really understand what the business is, we realize that it's difficult because really what we need is a domain. We need a plant information, a plant engineering tool. We need a chemical lifecycle management tool. We need a product lifecycle management tool to do all of this. And all of that technology is encompassed in this intellectual capital. That's the core business. It's what we make, how we make it, where we make it, right? And there's an overlap, a natural overlap to our resource planning technology. So if we just look at it in a little bit more granularity here, as an example, I want to buy a pump. Well, buying a pump on the left hand of the gray is your administrative tool. So even though it's sitting at the operations side or even at the engineering side, it's not an engineering function. It's not a domain process function. So that would sit in your resource planning technology. But making the pump, modifying the pump, distributing the pump, really that's sitting in your intellectual capital, right? Equally, if I'm buying a number of equipment to contribute to my plant, so I'm buying 1,000 pumps or I'm buying several thousand valves, that procurement process is administrative. But designing the plant, maintaining, constructing, and operating the plant, that's intellectual capital. That's domain capital that's sitting on the domain infrastructure. At the HR side, I always bring this up because clearly HR is all administrative, but who I give access to a project or a system or subsystem in my plant, whether that's a vendor or an internal employee, and whether they need to retrofit a piece of equipment or they need access to specific data sheets. That degree of access is not in your resource planning tool. You want that in your domain tool because that's where that information is sitting. That's where those changes are going to be managed. The logistics optimization, they need specialized access, simulation engineer, design engineer, that kind of thing. If I'm invoicing, of course, it's in your resource center or financial tools, while managing the specs, build the order, verifying quality with in your domain tool. So you see here on the left illustration, and then you see there where your core business is, which is intellectual capital. And we can just ask some simple questions. If you want to flow into other areas of the business, quite simply what we make, how we make it, who's making what, and how we address our market. So really the product we make, the plant that we use to make that product, and chemical products that we make R&D or extract, which could be oil, it could be polyethylene, it could be any kind of chemical product. So this really is segueing us into the solution to that, right? We understand the problem, we understand it at the enterprise level, and we understand we need to significantly leverage our best practices at the domain side. And really the way we have to do that from a technological perspective is to use technology that's available today. And we've moved really past the document and paper-driven approach, hopefully. Those are very limiting and constraining. I gave this perfect example. I want to have an access to a subsystem. Well, it's the document-driven approach. It's very hard to extract that area, that boundary limit within a facility. Well, what if I want to have access to that same subsystem across 3 or 4 facilities? That becomes really complicated from a document-driven approach. So what we've evolved to is really data-driven, object-oriented strategy. And that allows us to have that traceability across not only one project and plant, I think most people are used to that strategy across the plant, but across multiple projects and plants. So I'm going to talk about configured and integrated engineering management. This is something that collaborated with Rajul, my colleague. Sorry he wasn't able to make it to this recording. But really to put this piece together and understand from a information perspective, how does this work? What are the needs? So before we get started, we have another poll. If you can go ahead and fill that out. What are your feelings about systems engineering? Must-have, interesting concept. I don't think there's any value, and I've never heard of them. So please go ahead and fill out that poll question there. Appreciate that. So just looking at the integrated engineering view, really there are 3 pieces to this. One is the holistic approach to asset engineering or asset lifecycle management. The other is looking at the life cycle of the product. So or your plant in the full life cycle of that. And finally, you have disparate, essentially IT applications that need to be interconnected because you need information from one application to work in another application. And ideally, gone are the days where the way that we're extracting information is that we're going into the computer and writing them down on a piece of paper and then going into the other application and inputting them. Ideally, there's some automated way in the system to push that information from one point to the other, right? So we look at the holistic asset perspective. What we see here is that these systems cause change. So we have a lot of change. We have to execute those changes across different disciplines. And then we have to consume that information. So the example of the subsystem again, I have one subsystem in one plant, but if I have that subsystem across 3 or 4 plants and I want to leverage it, I want to execute the change. Let's say I change simply a valve in that one subsystem with the exact same subsystem across 3 plants. I want it to propagate out into that subsystem in the multi-asset view. And I want to maintain the traceability. I want to know where my source of change was. Now, if I have vendors contributing to that system, I want to also track that the changes that they're contributing into that system, because those changes impact the overall cost, the bottom line of the project. And that's what this holistic view is giving you. Now, if we look at the life cycle piece of it, from R&D, the process, into through the design changes and all the as-built and plant design, in comparing those different, through the life cycle, the different functional aspects of that, how each one of those are going to contribute changes, just intrinsically. I build something as built, as I'm changing the things on the facility, my documents are not maintained, or my documents are not maintained in a consolidated way. Well, what we see is that all of this is impacting the safety, the compliance, financial component of my project. So these are all interrelated. You can't dissect one thing and say, well, it's not a big deal to have an as-built different from my as-design, and not to have traceability through my documents, because that's going to cost me time and money. Right? And for managing the engineering data across the disciplines and across the different stages, we're really looking at non-standard point-to-point interferences on the IT side. So here, Rajul talked a lot about, it's not just about saying, here's my tool and it solves everything. It's about having an integrated strategy. And I'll show a little bit about that later, where it's, even with these different CAD and third-party data, we're able to import all of that and consolidate it into an integrated environment, integrated view, and use that to manage change, to manage the resources. So enablers for integrated engineering configuration. So things are changing, essentially same plant, same need for the plant, but the configuration may be slightly different. That may be just because of the location of the plant, the geographical needs. In certain countries may have certain compliance requirements. It may be because there's a slightly higher production that's demanded from the plant. So that configuration change, as those are changing, the integrity still needs to be managed. Now, that may be a change that happens at construction, where there's a modification that essentially changes the layout of subsystems or systems in the plant, or enhances that. The unified data and process modeling. So wanting a process model strategy of the infrastructure that's unified and leverageable. Authorization, so role-based privilege, how I give people access to my system. I want 100 vendors to be able to access their respective data sheets and documents that they need to see the system. I don't want to have to go in and manually do that or manually print out those things. I want to give them access so they can see a specific amount of data in one plant, plant 3, whatever they have access to, and scalability. So a lot of times on the domain side, this is where the challenges come. The domain tools are really good at, a couple hundred users accessing the system for design, or even for engineering document management. But when you want to scale that up, you want to give access to vendors or scale it out to more people within the organization, A lot of times the domain tools don't do that, so you see a lot of customers leveraging the resource planning tools, the ERP tools to do that. I've seen customers using things like Salesforce.com to do an engineering strategy. And that's driven out of a need because they need the scalability. And the domain tool isn't offering that scalability. So it's important to address all of these needs in the context of what the customer is looking for. And the multi-asset strategy brings in that demand. When you're starting to scale from one project, one asset on a platform, several assets, there's going to be scalability aspect to that. So really the way we're addressing this, as I touched a little bit on earlier, is this object-oriented approach. And the object-oriented approach gives us that flexibility. You can see all the different views, the process breakdown, the geographic breakdown, the work breakdown structure, and so on. You can see the different relationships. So I see, in this case, a control valve, and I see it in different views. I see it as a process view. I can see it as a project view. I can see it as against the timeline, and I can see milestones, and I can see documents that need to be delivered. Let's say you have tests that need to be done, mechanical tests, pressure tests that are done within that subsystem, and all the checkoffs that need to happen. That can be in the project view, whereas the process view might have a slightly different view where you're looking at data sheets and you're looking at the plant hierarchical view, right? But all of that is in the same environment, and the view is controlled by the access rights or the role privileges that I give to the tool. So the project engineer may have a different view, for example, than the design engineer. And then these objects can have a lot of attributes associated to them, and those then objects comprise the components of the subsystem and so on. So that, I think, a lot of us are familiar with. Now, where it becomes interesting, what I think is new to folks, is that I can take these objects and I can roll them across multiple projects on the same platform. So I'm not extracting, copy, paste, and extract of a project, importing it into another project. I'm literally pushing through that instance on the same platform. So if I then change this specs of this specific valve, it's propagated not only through my project, but it's propagated through several projects. So you've heard me harp upon this a little bit. I like this type. It really cuts into all the different areas of the intelligence and intellectual capital management, looking for that single source of truth. And at each one of these areas, you'll have domain needs. So plant facilities, you'll have things like maintenance. Well, when you're shutting something down, if it's a major maintenance project, it's going to impact the product. You can't push your product through that facility, right? And if it's a chemical plant, or if it has chemical components, like a chemical injection unit or something, then you have impact at the chemical level. So those are things that are not pushing into the facility. And you want to make sure that when you then bring this facility or the subsystem back online, that the product that is going to the facility is not somehow contaminated, right? So there's a lot of testing that happens in interweaving between these. So you may have things like lab information management, QA and QC management at the testing and shutdown side. Those things are not dissected, right? Those are pieces of each other. Here we talk a little bit about predictive and analytics. Of course, in this time frame, we won't be able to get into all the details, but there's new technology out there on the facility side especially, and we want to be in a situation where we are more predictive and less reactive. And also for things like ordering and things, you're doing it in these resource planning tools, but the specifications are coming out of your intellectual capital, your domain tools. So just to kind of summarize here, you have your plant engineering data management concept, essentially the tag and revision management, or revision and change management. You have the plant breakdown structure management in view. So I talked a little bit about the project view, but you also have the plant process view. And then you have the concurrent engineering across those projects, which is really the multi-asset engineering and information management. So you could do the multi-asset engineering, design, in a collaborative environment. You can do that across multiple assets. So let's go through this use case quickly. This is a very large company. They had over 20 and then more than 24. These are capital projects. So they have many projects, of course. these are the big capital projects that they had across the world. You can kind of see them laid out on the map. Globally, it impacted thousands of stakeholders. And actually, the system that we deployed there was giving access to thousands of users, internal and external. So I think in this case there was over 10,000 users accessing the system. And like I said, over 24 capital projects. All of the projects globally, and it impacted the assets, of course, the vendors, and also their internal teams. So this is what the plan was, the multi-asset view, and they instituted this strategy really because they wanted to use these two things over here, which is the multi-D engineering, which is the 4D, 5D, 6D engineering, and the field engineering, the project execution strategy. So they wanted this to digitize the strategy, but to do that, they needed to consolidate their 3D and detailed engineering technology. So that was their minimum requirement, was to take our 2D drawings, our P&IDs, our 3D, and let's import them into one platform. And you kind of see that here. What's interesting in this diagram is that you see these 5 legs. Those are competitive technologies. So those are going to be all the plant design tools. So this tool, in this case we use 3D Experience platform, doesn't really care that this is Intergraph, Bentley, or Katia. Importing all that information and offering that multi-level strategy. And likewise with detail engineering, right? So those are imported. And the other interesting piece, this is kind of a byproduct of this project, was the digital catalog. So they didn't only want the plant design, they wanted the equipment design, which came out of their vendors, their subcontractors. So what they did is they created an online form in the digital environment. They gave those vendors rights to access certain aspects of the system, and those vendors are able to upload that information, fill in the form, and upload a number of different CAD file formats, SolidWorks, ProE, different CAD file formats into the system, and then synchronize those CAD formats to the 3D model. So you get that level of granularity you typically don't get in the 3D environment. Now, what's also interesting about this is on the first project, they started to build this digital catalog, which then eventually was built by the vendor. And then by the second and third, they were able to use the digital catalog built off the first project to build on top of that. So they now have a very comprehensive online digital catalog of all of their equipment that they can use into different projects. With over 24 capital projects, they've built a substantial catalog to it. And then there's the synergy with procurement on the spec sheet side. They also did a number of things with barcoding and logistics planning using technology, and of course that fed into their overall vision on the field execution strategy. This is a dashboard, the front end view on the project side. So the project manager can see traditional, business graph, the S curve, the cost optimization, man hours, weekly manpower forecasting. Now what's interesting is I think most of us can see how this is done on one project, but now if I want to do a comparable of 2 projects, 3 or 4 projects, the project manager can overlay that or mash that into this dashboard. And more importantly is the information behind it, feeding it is all the real-time field information. So the field team is able to upload or input the information digitally, and all of that is then available in real time to your project team, your project manager, and they can do the status updates right here with and even drill down into any one of these. So by clicking on the graph, you can drill into the details of that. Just wanted to show this video. This is one of the projects to give some idea. You have the plot plan there. 3D CAD, again, in this case, you don't really care which CAD format. This is just a demo CAD, so it's not the real plan, and that's why I put those videos. But you see that we have the apps on the left. I'm able to instantiate an app. I can go through and take the original 3D plant model, and I can then build a project planning scenario out of that plant model. And one of the things that we did with this is that with the project schedule was, or the master schedule was sitting in Primavera. So what we're going to do here is we imported the master schedule, we we've already connected it to the 3D model, but we're now optimizing the master schedule. But instead of doing it from the schedule view, we're doing it from the plant view. So as we're going in and visually seeing, this is where the steel construction steel systems are going to be built at this phase, this particular milestone. You'll start to see there the calculation automatically of estimated man hours. We'll have resources coming out of the master schedule, but we can optimize those resources based on all the changes that we're doing graphically here. And that workflow diagram that you're seeing is essentially a 3D schedule that we're building. And then you're seeing a little bit of granularity here, so we can, double click and build at sub points. So within a milestone, I can have a number of action items. So I can have subsystems, and I can build that level of granularity. And that's what you're seeing there, with a big box is a major milestone, and underneath you have 3 tasks or milestones, minor milestones that comprise that major milestone. So I can see the overall timeline cost for the major milestone, but then I can break it down into different parts, which is nice because in a subsystem, a large subsystem, you may have part of it that is dependent on civil in the concrete, part of it is dependent on, piping, and then you start to build other pieces, and all of those then contribute to your major milestone. So you see on top there, 50 days, and over here, days 12, and that's coming out of original data. In this case, that was sitting in the master schedule. So all of that then is updated as I'm making changes and I'm drilling down. And these are done as a team. So in this case, the customer has a teaming room, and the team is able to collaborate in this environment like this and optimize it. And I think, so just here as we're going towards the end, I may fast forward it just a little bit, you'll see the schedule update. So hopefully this allows us to fast forward. So here you see here, we're just going through on a Gantt chart in the environment. It automatically creates the milestone line items, attaches them to the 3D. As you see, in this case, as I said earlier, those milestone items are already populated. We're just modifying them against the 3D model. And then hopefully here I can publish my milestones into my updated schedule. Well, I won't belabor that, but at the end of the video, I then publish the updated planning schedule to my master schedule, using from the one that I generated from the 3D model. So just to finalize here, some of the benefits of the multi-asset strategy. You saw in the video really one asset view. That asset was leveraged from a number of capital projects because we're in a multi-asset strategy. So much of that work was already optimized over the course of the project. And, it wasn't a project a project instance. It was all on the same platform, leveraging the same apps. So what can happen is if I'm a planning engineer, I can do my first plan, but if I have a task that's the second or third plan, I'm in the same environment, and I just click on the second or third plan. Okay. So this is just to summarize the multi-asset management strategy. Is the cost savings attached to that. In the case of that customer, they were able to save millions of dollars because they rolled this out across over 24 capital projects, from project to project. They got the scalability because one of the challenges with the domain technology they had was they weren't able to scale up. And as I said, in that case, there was over 10,000 users accessing that system, and they were not able to scale it up with the domain tools. They didn't want a resource planning tool to do the domain strategy or the domain functionality. The complex revision management, you saw a little bit of that in the video, and as we talk through that, is as I'm changing these things, those changes need to be propagated throughout the system in different views. So just as a small example is, as we change that plan in those subsystems, we needed that schedule to be updated, and we needed the master schedule to be updated, and that master schedule publishes into Primavera. So it's not enough just to change within your bubble, it needs to propagate throughout the entire system. The full transparency, one of the things that's a little hard to see in the video is that if I have rights to a projects or 2 or 3 projects, I just open up, log in, and I have those projects. I can see the status or whatever I have rights to, and I can see my app. And as I'm modifying and updating information, the management can see the reports. That's why I wanted to show that dashboard, because those real-time reports are showing you the updated status, and that's all interconnected using really essentially big data strategies on the back end of that. And then the full, complicated domain needs, engineering information management. So engineering information management, as you all know, is not the same as, financial information management. We do really need a tool that's capable and domain specific for that engineering and process engineering information management. On the bottom, you see some of the references. I showed you the NYAP over 24 capital projects. We also have this other one, Mango Bond, if you're ever interested. I have a really big use case for that, over 44 plants. Most of these other ones are going to be, 2 or 3 plants, so you don't have to right away start with an ambitious goal of, over 20, over 40 plants. But I just wanted to show you the magnitude. Our largest customers have over 100,000 users. And, that's not just with 3D experience, it's just to look out and see that this strategy is saving money. So we just have one more full question here. Is there value in multi-asset view? And you can answer there's 4 options there. Must-have, need more information, maybe there is no value. We'll let you go ahead and contribute to that poll.